There's a new AI model out of Meta that might just change how we think about artificial intelligence, called VL JEPA, and honestly, it's one of those rare moments where you see something and think, yeah, this could be what comes next. Not an incremental improvement, a genuine shift in how these systems actually work. So what makes it different? Well, here's the thing. Every major AI model you've probably heard about, whether it's GPT, Claude, Gemini, they all do the same basic thing. They predict words, show them an image, ask a question, and they'll generate text one word at a time until they've given you an answer. That's how they're trained. That's how they think, and that's what they optimize for. But this new system called VL JEPA, which stands for Vision Language Joint Embedding Predictive Architecture, throws that entire playbook out the window. It doesn't predict words at all. It predicts meaning directly. And once you understand why that matters, it becomes pretty clear that we've been doing this the hard way for a while now. Let me explain what I mean. Imagine you show a model a picture of someone flipping a light switch and ask what happens next. A human would say the light turns off, or maybe the room goes dark, or perhaps the lamp stops working. All of those answers are correct. They mean the same thing. But to a language model, those are three completely different answers. Different words, different tokens, totally separate sequences that share almost no overlap. So during training, the model has to waste enormous amounts of effort learning all the different ways humans might phrase the exact same idea. It's memorizing style and phrasing when all it really needs to understand is the concept itself. That's problem number one. Problem number two is speed. When you're generating text token by token, you can't actually know what the model is trying to say until it finishes the entire sentence. If you're building something like smart glasses or a robot that needs to react to the world in real time, that delay becomes a serious bottleneck. You're sitting there waiting for the model to finish writing before you can even parse what it means. VL JEPA solves both of these problems by skipping the text generation step entirely during most of its operation. Instead of predicting the next word, it predicts what the answer should mean, represented as a continuous vector in what's called an embedding space. Think of it like this. In traditional models, the answers, "the light turns off," and "the room goes dark," are miles apart because they're different sequences of symbols. But in embedding space, those two answers can sit right next to each other because they mean the same thing. That's the entire game. By working in meaning space instead of word space, you collapse a messy multi-option problem into something clean and learnable. Here's how it actually works under the hood. There are four main pieces. First, a vision encoder takes your image or video and turns it into visual embeddings. Then there's the predictor, which is the brain of the system. It looks at those visual embeddings, reads your query, and predicts what the answer embedding should be. There's also something called the Y encoder, which during training converts the correct answer into an embedding, so the model knows what target it's aiming for. And finally, there's a Y decoder. But here's the kicker. It barely does anything. It only gets used when you actually need human-readable text at the end. Most of the time, the model just lives in embedding space and never touches language at all. So what does this buy you? Well, the results are striking. They ran a really clean comparison where everything was kept the same. Same vision encoder, same data, same training steps. The only difference was whether the model predicted tokens or embeddings. The token-based model used about 1 billion parameters. VL JEPA used half that, and yet after 5 million training samples, VL JEPA was nearly twice as good at video captioning. It learned faster, scaled better, and kept improving where the baseline plateaued. That's not a tuning trick. That's a structural advantage. But the real payoff comes during inference, especially with video. Because VL JEPA outputs a continuous stream of meaning, it can do something called selective decoding. Instead of generating text every single second, it monitors the embedding stream and only decodes when something semantically important changes. In practice, this means you can cut the number of decoding operations by nearly 3 times without losing accuracy. For real-time applications, wearables, robots, anything that needs to understand the world continuously, that's a massive win. And it's not just faster, it's more versatile. The same model handles classification, retrieval, even world modeling. where it has to figure out which action caused a change between two images. In that test, it beat GPT-4, Claude, and Gemini, all of which tried solving the problem by describing what they saw in words first. Turns out, predicting meaning directly can be more effective than narrating everything and reasoning over the text afterward. Now, this isn't going to replace language models everywhere. If you need deep reasoning, complex planning, tool use, you still want a token-based system. But for perception-heavy tasks, especially anything involving video or real-time understanding, this approach just makes more sense. It's faster, cleaner, and more efficient. It shifts AI away from word prediction and towards something closer to how we actually think, where meaning comes first and language is just one way to express it. And that feels like the beginning of something new. And that shift is what makes this work feel like more than just another model iteration. Thanks for watching, and I will catch you in the next one.